In this video, we want to evaluate the integral of x squared over x squared plus 49. And we're actually going to do it 2.5 ways, I guess. It's 3 ways, but 2 of them are kind of related. So let's look at the first method here. So the first method, I'm going to rewrite it by doing this. So I've got x squared, and what I do is I'm going to add 49 to the numerator, which is okay if I subtract 49, because all I'm doing is adding 0. So it hasn't changed the integral. And then I'm just going to rewrite this as 2 integrals. So the first one would just simply be x squared plus 49 over x squared plus 49. This will be a dx here. And then the other part of it, the minus 49, I'm going to break it up over here. So this will be minus. And I'll leave the 49 outside the integral here. And I'm just going to put a 1 here. This will be dx squared plus 49 here. So now for this one here, x squared plus 49 over x squared plus 49, that's just equal to 1. So all I have here is the integral of 1 dx. So if you integrate 1 with respect to x, that just gives you x. So that's what we have for that one. Now for this one here, I'm going to use a formula. It looks like this. It'll be the integral of du, u is a function of x, over u squared plus a squared. If you have anything that looks like this, the integral of that would be arctan of the u, and this is a square here, du over u squared plus a squared. A is a constant, u is a function of x, and this is going to be u over a, like this, plus the constant of integration. And the coefficient here, 1, is divided by the square root of a squared, or a. So it looks like that. So now here, I have that formula right here. So I can just write this as minus 49. And then the integral of this, based on this formula here, would be arctan of u. In this case, our u is x. So this is going to be x over a. Here, I have 49. That's the a squared. So the a would be 7 here. And then the a divides the coefficient here, which is 7. And I got the constant of integration. And then just a little bit of simplification here. This is equal to x. 7 into minus 49 is minus 7 here. Then I got the arctan x over 7 plus the constant of integration. Now, instead of doing this procedure, which comes out pretty nicely here, we could just do a long division here. Started off with this over here, x squared over x squared plus 49. So I could go ahead and just say, okay, let's divide long division x squared, or the numerator divided by the denominator. And this would be x squared plus 49, and we just do the long division. So x squared, have it in descending powers here in the divisor, and the dividend here. So x squared into x squared is 1. Multiply 1 times x squared is x squared. 1 times 49 is 49. And then we subtract here. X squared subtract x squared cancels, and 0 subtract 49 is a negative 49. So that's another approach. Other than that, it's pretty much similar to this here. And this is your final answer for that one. Now the other way we're going to do it, and if you find another way, please post it on the description, please. I'm going to use a trig substitution here. I'm going to let tangent of some angle theta equal to x over 49, or I say x over 7, because my triangle is going to be this right here. Got theta there, and then it's x here over 7 there. And then the hypotenuse here is going to be the square root of x squared plus 49. And so here, if I multiply through by 7, I'll get x is equal to 7 times tangent theta. So dx will equal to the derivative of this right side here. We have the constant 7. Derivative of tangent is secant squared theta d theta. And now we're going to transform this integral here into one involving the variable theta. Go from x to theta. So we have the integral. So what do we have here? We have x squared. So let's look at x squared, but x is 7 tangent theta. So I can replace the x squared by 7 tangent theta squared. That was replacing the x by 7 tangent theta. And then I can replace the dx right here by this. That would be 7 secant squared theta d theta. Now I need a substitution for the x squared plus 49. So let me just go down here. X squared, but x is 7 tangent theta. So if I square that, that's 49. 7 tangent theta squared gives me 49 tangent squared theta. And then this is plus 49. Factor out the 49 there. This will give me tangent squared theta plus 1. But tangent squared theta plus 1 is an identity, and that's equal to secant squared theta. So now I can replace then the x squared plus 49 by 49 secant squared theta. So let's do some simplification here. Secant squared theta divides out there. And then out of this one here, I'm going to get here, square this out. This is going to be 49 tangent squared theta. Okay, so this 49 tangent squared theta replaces this part right here. But then the 49 and the 49 divide out. So that's going to leave me with 7. And it's the integral here. 7 tangent squared theta d theta. Okay, so we got it down to this point. Then I'm going to use another identity again. Basically the same identity. Tangent squared theta, that's the same thing as secant squared theta minus 1. And this is d theta. And then we just integrate it here. So I'm integrating with respect to theta. So secant squared theta, the derivative of tangent is secant squared. So the integral of secant squared is tangent theta. Derivative of tangent is secant squared. This would be a 7 here. Then for this one here, integrate minus 1 with respect to theta, that's theta. But then I got 7 out here, so I multiply by 7 here. That'd be 7 theta plus the constant of integration. Now we have to go back to the original variable. So here's where we go to the triangle over here. So first of all then, I've got here tangent of theta. So look at the triangle. Tangent of theta, opposite over adjacent. So this would be tangent here would be x over 7. And you got a 7 out in front. So this is going to give me x here. And then I need theta now. So from this result here, tangent theta is equal to x over 7. Taking tangent inverse of both sides, I'll write it as arctan. Taking arctan both sides. Then on the left side I just get theta, and on the right side I get arctan of x over 7. So I just come back here then and replace the theta then. So this would be x minus 7, and theta from this result right here is arctan of x over 7 plus the constant of integration. So the final answer, working it this way, which is the same answer I believe that we got, you can double check it there, x minus 7 arctan of x over 7 plus your constant of integration. And you can see that the last result, the last method that we did was a little bit shorter than this one here. Thanks for watching. Any comments you have are appreciated. We'll see you next time.